Use the mass times acceleration, Luke. Hey guys, here we go. We're going to do Newton's second law. This is our intro. This is a little overview of what you're going to experience in this unit. So, let's kick right off, yeah? So Newton's second law deals with force, and it essentially states that force on an object is going to equal the mass times the acceleration. Okay? So Newton's second law is essentially this formula. Force equals mass times acceleration. Just a pro tip. We know physics loves algebra, and it's so easy to rearrange stuff and get different formulas. So if we're trying to find acceleration, you know these are multiplied, so we just divide this over. Zoop. So divide. So we know acceleration equals what? Well, force divided by mass, right? So, just two ways to look at this. So force equals mass times acceleration. Acceleration equals force divided by mass. So the acceleration on an object is directly proportional to the force. In other words, you double the force, you probably double the acceleration, and it is inversely related to the mass. In other words, you double the mass, you cut the acceleration in half. So we'll talk about that more a little bit further on, but let's talk about just a few vocabulary words that honestly, I'm just picking a few that I liked, so there's no reason why I'm defining any of these and not defining others. So mass, we know that mass is just the amount of matter in an object. Acceleration is a change in speed. So a change in speed. So if an object's going 10 miles an hour for an extended period of time, well, it has no acceleration, right? Because it's not changing in speed, right? So friction is essentially like drag. Terminal velocity. This is one that only a few people know, so I wanted to talk about that one. Terminal velocity. The word terminal means like to end. So, you know, there's a terminal in a, what is it called? Airport. It means like the ending point. You know, there's a lot of things that they use terminal for. So that means end or stop. And velocity is your speed. So what does it mean to stop your speed? Terminal velocity. So terminal velocity is something like, let's say I go in an airplane. I want to skydive. And I jump out of the airplane. And I don't pull my parachute. I just fall, right? So terminal velocity, you know when I'm jumping, you feel that you see people's cheeks get pushed in, right? And that's because the air is pushing back at them as they're falling. Or there's a certain point where you gain so much speed that the friction of the air, that force is equal to your acceleration downward. So in other words, you can't go any faster. Like you jump out of a plane and you literally you've maxed out your speed. You've hit your governor, you know, for people that drive cars. And I want to say for a person at like lying like flat when you're skydiving, I want to say it's around 122 miles per hour. Like at that point, you're not going any faster. You're just going at 122 miles per hour down towards the air. So that's terminal velocity. We'll talk about these two, but in short, contact force means touching. Distance force means like not touching. Number 11, net force. This is an important thing we'll talk about in this unit and the next unit. Net forces means like the overall force. So if, you know, I'm pushing the car one way and someone else that's smaller than me is pushing the car the other way, I'm probably going to win because maybe I'm a little stronger. So the net force is, let's say I'm pushing the car to the right. The car's getting pushed both ways, but the net force is going to be to the right because maybe I'm a little bit stronger than that other person, right? So the net force just means the overall force, like what direction's winning kind of thing. So, okay, so there's that. You're going to label the forces. I mean, it's pretty simple, guys. It's not very hard. It looks a little scary. Do a few problems, piece of cake. If you guys got any questions, let me know.